Hey, P Physics C, this is Horner, and we're looking at 2001, number one. This is a very, very great problem just because it's a lot like a lab that we do. Notice that we're recording for an object. We're looking at its speed. So here's the setup. You have a cart which comes down and hits a force sensor. The motion sensor tells us the velocity versus time, and the force sensor gives us this peak. Very similar to what we did in the lab. So they want us to find the cart's average acceleration between 0.33 seconds and 0.37 seconds. So the easiest thing to do here, we know, is to use acceleration is equal to the change in velocity over the change in time. So let's find our change in velocity. Final velocity at 0.37 seconds looks like it's about 0.18. So we'll go ahead and put in negative 0.18 meters per second. So do notice it's negative. And then up here it looks like it's about 0.22 positive. So we'll subtract the positive 0.22, and that'll give us the difference in the velocity. Change in time for this one is the 0.37 minus the 0.33. And when you solve for that, you get something very close to gravity, which is negative 10 meters per second squared. And that is the easiest part to do. That's worth 2 points, 1 point for coming up with it, 1 point for plugging everything in and getting the correct answer. For the next part, for letter B, it says determine the magnitude and the change of the cart's momentum during the collision. So all we've got to do here really is just find the area under this graph. It's pretty simple to do. You could really do a little triangle here, a little triangle here. You could do the square, so I'm going to just kind of separate all these. Little triangle, little triangle. You could do the rectangle here, and then you want to do each one of the right triangles here. If you add all of those together, you should, whoops, that's kind of funny. You should end up with the area under the curve. So the change in momentum here is equal to the area under the curve. You always want to look to see if they give you that. They actually don't give it to you, so you'd have to calculate it. But the area under the curve here should be equal to zero point 0.6 newtons times a second. Remember, area is the y-axis times the x because this one is force and this one is time. We end up with this answer. So that one's pretty easy to do too. Letter C says determine the mass of the cart. Now that we know the change in momentum, so change in momentum we said was zero point 0.6 newtons times a second, because remember your force times time is the same thing as m delta v. So the change in momentum, which is also the impulse, is equal to m delta v. So we're going to do delta p is equal to m delta v. So if I want m, I'm just going to do the change in momentum over the change in the velocity. Change in momentum was 0.6. We know the change in velocity was 0.4 meters per second, so that comes out to be 1.5 kilograms, which is really simple again. For the very last part, all they want you to do here is determine the energy lost in the collision between the force sensor and the cart. So for this one, we know that the change in energy is going to be equal to the absolute value of the final energy minus the original energy. Our final energy is equal to 1/2 mv, the final velocity of the cart, minus 1/2 mv, the original velocity of the cart. And probably the easiest thing to do for this is just go ahead and factor out the 1/2 m, so 1/2 m, and it's just the final velocity squared minus the original velocity squared. If we go back up and look at the speeds, we talked about those speeds earlier. We said that they're probably somewhere around negative 0.18 and 0.22. So we'll go ahead and plug those in. So this is negative 0.18 squared minus 0.22 squared. And so this is equal to 1/2 of m. And our mass, if you remember earlier, we solve for it is somewhere around 1.5 kilograms. So we'll just put that in right here, 1.5. So now you need to do your math, and when you're done, you should end up with 0.012 joules, and that is the energy lost in the collision between the force sensor and the cart. And that is a very simple AP Physics C problem. Just adding to this problem, remember they're looking for the change in energy. So we did say that that is the absolute value. The value that you'll get will be negative 0.012 joules, but because we're looking for just the energy lost, we're just going to call it the absolute value, so that just makes it 0.012 joules. Same thing. Negative means it's lost. Here we're just going to say that that's the change in energy, or what happens to the energy. So it is essentially the same thing. That's it.